Good afternoon, everyone. Thanks for taking the time to do this. All of you must have used ChatGPT, and some of you might have also used ChatGPT Plus, Copilot, Gemini, etc. Today, I want to show you how people are using AI tools to speed up development. Let's first look at the tool named MakeItReal. This tool can convert a sketch or wireframe into code. This is an open source project. As you can see in the video, once the sketch is ready, we can add text to explain functionality, and after submission, it will use the GPT-4 Vision API to understand the sketch and provide the necessary code. If we want to use it, we can generate an API key from OpenAI, or we can use it locally, as this is an open source project and the code is available on GitHub. Next, I want to show you this tool called ScreenshotToCode. It does exactly what you expect from it. Using a screenshot, it will create a similar UI using HTML, JavaScript, and Tailwind. This is also an open source project. In its recent updates, it can now take screen capture video as input to create better code with more functionality. By now, most of you would have heard of Devon, created by Cognition Labs. They call it the first AI software engineer. You might have seen this chart comparison for Sbench. Devon was evaluated on a random 25% subset of the dataset. Devon was unassisted, whereas all other models were assisted, meaning the model was told exactly which files needed to be edited. We don't have access to Devon yet, but we have a similar open source project by Princeton University researchers named SWE Agent, which is similar in performance to Devon. One interesting thing to look at here is that Opus is performing far better than GPT-4, which is a model developed by Anthropic and available at the same price as ChatGPT Plus. Now let's look at what Sbench is and what do these 12% and 10% mean. Sbench is an evaluation framework consisting of 2,294 software engineering problems drawn from real GitHub issues and corresponding pull requests across 12 popular Python repositories. Given a codebase along with a description of an issue to be resolved, a language model is tasked with editing the codebase to address the issue. That 12% means that out of 2,294 problems, 12% were solved by that LLM or framework. Those who want to know more can read this paper. Enough talking. Now let's do something. Here I'm trying to write code for the Tetris game using ChatGPT. Okay, it gave me some code. Let's give it a try. It looks like it is going in the right direction, but I was expecting better. Let's try to improve. You can see in the prompt where I am proposing ChatGPT some monetary reward for better performance. It sometimes works. Well, it didn't this time. After some more back and forth, we reached this, which is better, but not exactly what we wanted. Now let me show you the power of custom GPTs. First, let's discuss what a custom GPT is. A custom GPT refers to a version of the GPT that has been tailored or customized for specific applications or needs. Now, even though a good prompt engineer would have gotten the correct code in 1 or 2 prompts, maybe I am a noob. So let's use a custom GPT created for those who don't have enough prompting skills. This is called Prompt Perfect. It will just take our message, understand our intentions, and modify the prompt before giving it to ChatGPT, which should give better results. It gave us HTML and CSS. Now I'm asking for JavaScript code. And we got some errors, and it's telling us we are milling an element in HTML. Let's update HTML and CSS, and now it's working. But pieces are not rotating. After some back and forth, we have gotten it working. So this was a much faster and less frustrating experience compared to core GPT. This is just me showing my Tetris skills. Now let's look at some more custom GPTs. This is called Web Pilot. It has better internet surfing functionality than core GPT-4. This is Code Copilot. If I wanted to build a bigger project, I would have used this instead of Prompt Perfect. There are many good GPTs, but I am just showing a few. In the beginning, we saw a tool for converting screenshots to code. Someone has created a custom GPT with somewhat. I just sent a screenshot without any text, and this is the result. I know it's not good, but it can serve as a starting point, and if we put some effort into providing a screenshot and some details about the requirements, we can get better results. Then there is this custom GPT for MakeItReal as well. Then there is this tool named LM Studio. This is software that helps us host local LLMs. Here, we can download any open source LLMs that are available on Hugging Face, and we can either chat or create an API to use in our software. As we can see, I have turned off the Wi-Fi network, and now let's ask the question, what is the difference between .NET Core and .NET Framework? And as you can see, using PHI-2 LLM, which is a 2 billion parameter model developed by Microsoft, we were able to get the answer while using my laptop's CPU to perform the required computation. Now we can turn on the server and use this API to integrate LLM functionality into our software.